Where have all the polygons? Parker's still not back from picture. That way must be good. With polygons, we've talked about this before, so it's a good refresher here. When you talk about polygons, you have what we call similar polygons. And we have what are called congruent polygons. What is the difference between the two? Avram.
Congruent is the opposite.
Congruent is exactly the same, thank you. It has to be exactly the same, both size and shape. For example, this square, and I'll do my best, and this square are exactly, that second one might be a little bigger, are exactly the same. Similar, on the other hand, Brant, is?
Like it's not exactly the same, but it has to be kind of the same.
Yeah, kind of the same. It's the same shape. Okay? In other words, you have this. If you have this triangle, you have this triangle that would be similar to it. Okay? Now you have to remember, we talked about this before, when you talk about similarity, you have to keep in mind that not all triangles are similar. It's not because they have three sides that make them similar. You have to think of what I like to call my balloon theory. In order for something to be similar, one side, it has to expand or get smaller at the same rate, like a balloon would. When you have a balloon, it doesn't just blow up on one side, all sides get bigger on the equal side. So these triangles should be similar, but this triangle would not be similar to that triangle. Because this is like a short squatty triangle, this is like a tall whatever triangle. So these are not similar, these would be. Some shapes are always similar. For example, what? A square. Squares have to be similar. Why? Because they all look just like, all four sides are the same. They grow at an equal rate. It's a little like this. When things are similar, we call their sides are what we call proportional. Which means this. If this side right here was 4 and this side was 8, that means this second, everything on the big triangle has to be 2 times the size of the other triangle. 4 times 2 is 8. If this was 6, that would mean this side would have to be 12, and if this was 6, that side would have to be 12. Okay? And when we talk about that, we say this. Great. Why couldn't I put all of this on top of my thing? Let's see if I can move this. What are the chances? Anybody? I give me about a 0.5% success rate on this. Wait, you know one thing I can do is just watch. More than one way to skin a cat. Why isn't it going? Somebody?
Thinking.
No, no!
Mr. Hunter will go whatever way you want.
It won't go because now that I have just lost the entire thing. Even if I push X, it's going to go away. So, I got to restart here. Hold on. Don't worry. Or maybe you should worry. Let's see if I get something back here. I played the sound effects, but the sound system isn't on. I don't even remember what my train of thought was. What was it? It was proportional. Some of the things were proportional. Oh, I know what it was. We'll go back to it as soon as this goes here. Which means this. Let me get a shape here. Let's say you've got this triangle. And you've got this triangle here. Well, no, I don't like this triangle. Can I switch that? Yes, I can. Let me go to right triangles here. Let's say you've got this triangle, and you've got, tell me where you think this one is proportional. So it's about proportional? Sure, why not? And let me label these. A, B, C, D, E, and F. In math, we have a little thing that's called corresponding sides. Corresponding sides. And basically what that means is when you look at similar shapes, corresponding means the same side on the bigger as on the smaller, which won't make no sense until we discuss this here. In other words, this. If I asked you what side on the little triangle corresponds to side CA on the big triangle. CA on the big triangle corresponds, and we do this little shaky rolly kind of thing there, because that doesn't mean equals, but corresponds. What side on the little triangle corresponds or is kind of the same side on the little triangle? Well, you look at this. CA is the shortest side on this. So the shortest side on this would be its corresponding side over here. So it'd have to be side ED. Or if I said corresponding EF on the little triangle corresponds to what side on the bigger triangle? It's the longest side, which is what? CB. Okay, and you have to be careful because the book will at times take it and spin that around. It's not like it's always in the same, going to be in the same length there. Don't get cross these off and put it back in somewhere else. Whatever it was, B, C, right, B, D, E, or whatever it is. Okay, you just have to look at, no matter how it's rotated, side AB. Side AB is like the middle length side. So you go look at this one and say, which one is my middle length side over here? It would have to be that side. And corresponding sides are what we call proportional. See how far they give you with proportionality here. Let's see if there are options here. Yeah, write this problem down right here. The book gives you two triangles that look like this, right? Try and draw these two triangles as best you can. And it says 5, 12, 5, 3, 6, 12, 15, and 5 over here. Is that right? 6 over there. Okay. Now, here is the question. And again, don't go by looks. We're going to prove this mathematically. Are the triangles similar? Are these two triangles similar, and how do you know? Abram?
No,
Why not?
because on the left side, 6 doesn't go into 15, 5 doesn't go into 12.
Well, what have you proven me by that?
Because if it's supposed to be similar, it's supposed to
It doesn't have to always go in evenly. But you're on the right track. I just want to make sure we're on the same thing here. How do I know? He's right. They are not similar because they're not proportional. Why do you know for sure they're not proportional? You went with 6 and 5, but I'd go with the other side. This side corresponds to what side on the other one? This one, correct? Well, 3 times what is 6? That means for these to be proportional, all the other two sides would also both be times 2. And it's not, because 6 times 2 is 12, that makes this 15. And because this is 5 times 2 is 10, you don't get that. So they are not proportional. Not proportional. You know, if you had a triangle that looked like this, and it said it was proportional to a triangle that looked like this, let's say this is 1 and this is 8. If this is 3, you can tell me how long this side is. How long would it have to be? Well, what do you do from 1 to get to 8? Multiply by 8. So every other side would get multiplied by 8 to get this. So 3 times 8 is, this side would have to be 24. Now you don't have to worry about it with congruent because congruent, everything's the same. You can't change anything around. If one side is 5 on one, it's 5 on the other one. Now with that being said, children, here we go. We got all sorts of things here. No, I guess we gotta go back to this one here. Write this down. Similar, this is still in the same notes. Similar shapes will have, similar shapes will have corresponding angles that are equal. Similar shapes have corresponding angles that are equal. And by that, we had a problem like that on today's homework. Let's say you know that these are similar shapes. The book tells you they are similar. If this side is 70 degrees, okay, that means on the other quadrilateral, the other parallelogram, whatever angle corresponds to this, which would be this one, correct, also is 70 degrees. By the way, anybody know how many degrees that would have to be? I was thinking, huh? Why?
Because a square is the entire thing is 360 degrees, and if the angles are both the same, you have to divide by 8 by 2.
Yeah, and in a quadrilateral and in a parallelogram, a couple things are true. The opposite angles are equal, and the angles that touch each other are what we call
Straight.
yeah, they'll be straight angles, which we call what? You know what we call that in math when they're straight angles? Not complementary, but supplementary. So this and this have to add up to 180 degrees. This and this have to add up to 180 degrees, which would mean all of these are just alike. Now, lest you were confused enough, write this down, and it's the same notes. This is called side, side, side. Side, side, side. This is, by the way, geometry stuff. Triangle similarity. And what that says is this, ladies and or gentlemen. This is my little box here. That says this. Oh, I guess we already said that. Not so many words. If the sides of a, I guess I should put, if the corresponding sides of two triangles are proportional, what would be true? If the sides of corresponding sides of two triangles are proportional, then they are what? We already said it. Somebody? Anybody? Similar. It's kind of like just going the other way. It's kind of like going backwards from if they're similar, they have corresponding sides. It's the same if they have corresponding sides, they are similar. And then the other one that you should write down in your notes is one that's called angle, angle, angle. Guess what it says? Oops, what happened there? If in two I don't know if I want to write this down. If in two triangles all angles are congruent or exactly the same, what's going to be true? If you have two triangles and all the angles in both of them are congruent, wait,
Equilateral?
no, we're not, but it means, I guess I said that wrong. If in two triangles, not all angles are congruent, but all corresponding angles, I guess I have to say. All corresponding angles are congruent. You're right, if they were all equal, it would be equilateral. If all corresponding angles are congruent, then the same thing is true, they are similar. So angle, 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 side, side, side. I don't know if that helps you out or not. Isn't that exciting? One more problem here before I set you free and shall be free. Let's say you've got this triangle here. It's a 3, 4, 5 triangle. And you have this triangle here, which is similar to it. That is a 15, 12x. How would I find x besides saying there it is? You know, the book would tell you that these are corresponding, or these are similar triangles. Grant,
You would find out what, like 5 times 3, 5 times 5 divided by 15 would be 3, so that you would multiply 3 times 3 would be 9.
what do we call that? Anybody know? When you multiply 5 times 3, it's 53, right? It's 15. What is this number called? Anybody?
Scale,
Tyler?
scale factor.
The scale factor. Factor means what you multiply by, scale means you're going to a bigger scale, so or smaller, either way you can divide by it, still be the same scale factor. 4 times 3 is 12, 5 times 3 is 15, so x would have to be 3 times 3 is 9. You could also draw a table, by the way, to do that. It's a ratio, it's proportional, and this is what it would look like. You've got the small triangle, and you've got the big triangle, and on here you'd have to pick whatever two sides you're talking about. What's this? This is the shortest side, so let's put the short side here. And then let's put the long side here. Well, the long side on the big triangle, or let's do the long side on the small triangle is how long? 5. Long side on the big triangle is 15. Short side on the small triangle is 3. Long side on, or short side on the big triangle is the one you don't know. So there's your ratio / proportion box, and it all works the same way. Times 3 times 3.